Basically two types of regularization, and I've already said what could be the values of P 1 and 2, right? And based on moral so based on what the values of P are, and based on whether we are using a modulus or not, we define the L1 and L2 regularization. So before that, before we understand what L1 and L2 are, we'll try to understand in terms of the loss function, L1 loss function and L2 loss function, and then becomes easier to understand L1 regularization and L2 regularization. In L1 loss function, so loss function is nothing but your difference between your target variable and then what you actually get from the your model, right? So this is what we get from the model, and this is the target variable given. When we take the difference, we actually get the error term, and when you take a summation of that, summation of yi minus f of x, right? When you take the modulus of that, we call that as L1 loss function. We can also call this as least absolute regression, right? So yeah, so this is the modulus. On the other hand, we can also take the square, right, which is more popular. Least square itself is more popular than the modulus one, right? So instead of a modulus, we have just taken square of that. So what happens is modulus is that the error terms becomes positive. All the error terms they tend to become positive, and then when you do the summation, and there is no issue. Otherwise, they will cancel out, and it will tend to be 0. Whereas here we are squaring the error terms before adding them up. Okay, so it is just the difference in which we are making all the errors positive, right? The first one we're calling it as L1 loss function. The second one we're calling it L2 loss function. So this is L2 loss function where we have a least square case. We are summing this square of the error. Where this is in the first case we are taking the modulus of the error and then summing. So that's L1 loss function. So this is the difference between the formulation of loss function. Regularization L1 and L2 regularization both are of similar type. Okay. One thing to remember here is that in the first case we can have multiple solution. We can have that. Whereas in the second case where we have a least square, we always have a single solution. Okay. So we have a closed form solution in this case, where in the first case we may not have a closed form solution. The first one we also call that as a lasso regression, okay, and the second one we call that as a ridge regression. We'll see a bit of it. Okay, so how do we relate this to regularized terms? Now we have learned about the L1 and L2 loss functions, right? But what is L1 L2 regularization? So here is what L1 L2 regulations are. In the L1 regularization, we have come across this regular addition of regularized term to the least square. Now this is the least square, right? This is the least square regression cost function. We have added this one, which is regularized term, to this. Now if the regularized term is summation of the modulus of the betas or modulus of the weights, is just the W has been used instead of betas as the weight. Okay, so that we call that as L1 regularization. On the other hand, if we are summing, or we are taking the sum of the these squared sum of the square of the beta parameters, then we calling that as L2 regularization. It's similar to what we have seen for the L1 L2 loss functions. If you're taking modulus, it is L1. If you're taking square of that, it is we essentially calling it as L2 regularization. Okay. So this section we call that as a lasso, and this we call it as a ridge. Okay. So these are simply additional names to the So depending on what you use, you actually call by the name. Okay. Alright, so what are the uses? I've already said about it that we actually use Lasso and Reach to overcome overfitting. Secondly, to select the best possible set of features for your model, so that the prediction accuracy is quite good. So that's the intention of using L1 and L2 regularization. So finding optimal weights is a challenge, right? So what is the optimal weight by using L1 and L2? Okay, so that is the biggest challenge. Okay, so there are several ways, several techniques in which one can get to find the optimal weights. I'm not going to talk about it. We'll see that in an example in one of the next videos, where I'll take a data and showcase you L1 and L2 regularization, and see how we can optimally find out the best set of optimal weights. How we can tune the weights, how can we can find it out a suitable set of weights which will be very good for prediction. Prediction accuracy is supposedly supposed to be improved once you use L1 and L2, and whether to you go for L1 or L2 will also depend on quite a number of things. Sometimes L1 will do better than L2, sometimes in other way around. There's no science behind it, but there's always good to try both and then see which one is working better, or better on your test data. So we'll see one example to understand what we have learned, the theory that we have learned so far, and that will be better and more clearer. Thank you so much.